This is flipped class video number 12. In this video, we'll talk about Python set, another composite variable in Python. Just a very brief review. So far, we've introduced three different types of composite variable. A composite variable is a variable that can carry multiple values. So today we're going to introduce the fourth composite variable, the Python set. Python set is an unordered collection of unique elements. And also set is mutable. That means you can change the element in the set. So there are three different properties for a set. 1. It is unordered. 2. The elements of sets are unique. And 3. Set is mutable. This is how you declare and initialize a Python set. You initialize and declare a set variable using the curly bracket. Note that both the set and dictionary use curly brackets. So you can actually consider set as a dictionary without its associated values. So it is just the key without the value for a dictionary. Okay. So you can also initialize an empty set using the set function. Alternatively, if you have a list of items, if you have a list variable, you can use that list variable to feed into the set function to initialize and declare a new set. So as we said, one of the properties of Python sets is unordered. That means the order of element in a set, it does not matter. Here we have two examples to illustrate this property of a Python set. In the first example, we have two sets, set x and set y. Both set x and set y consists of three elements. For set x, it has three elements, 3, 5, and 7. For set y, it also has three elements, 5, 3, and 7. Note that the order of set y is slightly different from set x, and they have identical elements. So if we make a comparison between set x and set y, even though the order of the element is different, it consists of the exact same elements. So Python sets consider them as identical. So if you make a comparison, the result that you're getting is true. They are the same. So set x and set y is exactly the same. It's exactly the same, even though their order is different. Similarly, in the second example, you have two sets, set A and set B. They have identical elements, but the order is different. John, Mary, and Mary, John. So if you make a comparison between set A and set B, you will get the result true. Another property for Python sets is that the elements of a set has to be unique. That means you cannot have duplicate elements. Here in the first example, you have a set x, which consists of, well, you're trying to initialize the set x with four elements, 3, 5, and 3, 5. Since the second 3 and second 5 are duplicated elements, that is not allowed in set, so it automatically got eliminated. So actually the values stored in sets is only two elements, 3 and 5. In the second example, we declare a set y, which consists of three elements, John, Mary, and John. The second John is a duplicated element, and it will be eliminated. So when you print out the contents of set y, you'll see that there's only two elements, John and Mary here. In the third example, similarly, first of all, you create a list. The list consists of four items, 3, 5, 7, and 7. It's okay to have duplicated element in a list, so there's no problem. So if you print out the contents of the list, you'll see that list 1 consists of 3, 5, 7, and 7. But if you use that list 1 to initialize a set, if you feed that into the sets function to initialize set z, then you realize that the duplicated element will be eliminated. So set Z consists of 3 elements, 3, 5, and 7 only. We also mentioned that sets is mutable. That means you can change the elements of a set. Here in the first example, we set up a set X which consists of 3 elements, 3, 5, and 7. So we can use the add function to add an additional element, to add a 9 in set X. So now set X becomes 3, 5, 7, and 9. And notice that if we further want to add an additional element, and if that element is duplicated, then that element will not be added to the set. In this case, if you're trying to add a 3 into set X, then set X will remain unchanged because there's already a 3 inside of set X. There are 4 special operations you can perform on Python sets. The first one is the set union. Set union means combining 2 sets. And if there are duplicated elements, the duplicated element will be eliminated. Here we have 2 sets, sets X and sets Y, and they both consist of 3 different elements. Notice that they have one common element, which is 7 between them. So we can perform a set union using the vertical sign. Okay, so set X, set union with set Y, and assign the resulting values to its new set called set Z. So when you print out the value of set Z, you realize that it consists of 5 elements, which is basically the combination of both set X and set Y, with the duplicated element eliminated. Set intersection would return the intersection between the 2 sets. That means the duplicated element only. Here in set X and set Y, the only duplicated element is 7. So if you perform a set intersection using the AND sign, that will return the intersection of the 2 sets, which is 7 only in this example. In set difference, you eliminate every element within the second set from the first set. Here in this example, you search for set Y and find out which element is duplicated from set X, and then you eliminate that element from set X. Okay, so in this example, if you use set difference, set X minus set Y, the result would be removing element 7 from set X. So the result is if you have a set that consists of element 3 and 5. Symmetric difference is to eliminate the duplicated element only and then keep everything that is remaining. Okay, so a symmetric difference between set X and set Y would remove the duplicated element 7 and keep everything, that is 3, 5, 9, and 11. Similar to list and dictionary, you can perform a set comprehension just like list comprehension and dictionary comprehension. Here in the example, you apply the function 3 times x to a list, which is a range from 0 to 9. Okay, and there's an if statement at the end. So you apply the function if x is larger than 5, then that will produce the sets for 6 times 3, 7 times 3, 8 times 3, and 9 times 3. So the result will be 18, 21, 24, and 27. And similar to list and dictionary, here's a set of some other common operation you can perform on Python sets. You can add an item, remove an item, get the length of the set, check the membership, check whether an item is in a set or is not in a set. You can also delete all items within a set. We'll come back in the lecture to illustrate some of the examples of how to use sets during the lecture time. So I'll see you in the lecture.